Okay, if you haven't watched the video about defining a sine wave, go back and look at that first because I'm going to be relying on some of the information there to describe what we're going to be looking at here, which is a cosine wave. So if you want to know like why are these points where they are, what does this mean, what is a periodic function, all of that information is included in the other video about sine. But we're going to be looking at our cosine wave right now. Now, some things are similar in that here we're still plugging in angles. Okay, now the way this is written, y equals cosine x, might be a little bit confusing if you look at y equals sine of x. But for any trig function, the input will always be an angle. We're always putting angles in here. The output is unique for each function. So like for a sine wave, we said that the output is a y coordinate. So when you look at this, this kind of makes sense. When I write a cosine function like this and you see y here, it's not because the output of a cosine function is y, because the output of a cosine function is the x coordinate from the unit circle. And we've discussed that at length over the past couple of weeks. You should be comfortable with this by now. So if I go to create a table of values like I did with the sine wave, these are going to be angles, and these are not y coordinates on the unit circle. These are x coordinates on the unit circle. So if we start with 0 and get my unit circle here, at 0 radians right here, what is the x coordinate? The x coordinate at this point is 1. At pi over 2, which is right here, the x coordinate is 0. At pi, the x coordinate is -1. At 3 pi over 2, it's 0. And at 2 pi, we're back to 1. So these are the points that I'm going to be plotting over here on my x and y axis. So this ordered pair, 0, 1, x is 0, y is 1, that point's up here. I'm actually going to change to a different color here. Let's go green. So that point is up here. At pi over 2, we have a value of 0. At pi, we have a value of -1. So we move over pi and down -1. 3 pi over 2, we have an output of 0. And at 2 pi, we have an output of 1 right here. And just like when we were talking about the sine wave, to create this graph, it's not a spike. Okay, a spike would indicate that we have a constant rate of change that gets us from 0 to pi over 2. But a curve is not a constant rate of change. So we basically start here, we flatten it out, and we want to try to hit this going straight down. Again, this isn't going to look perfect because I'm on this tablet. But then we curve to get towards this point. We curve and come up, and then we bend at some point to make it back up to here. So here's the basic outline of our cosine wave. Okay, again, we have 5 critical points, just like we did for sine. Okay, and this was described in the second video. The period still goes from 0 to 2 pi. So period meaning this. If I take this curve and copy and paste it, I could take this and move 1 to here, and we would have that wave. I could take one of these, it's probably going to jump off the screen, and move it over to here. And what you get is this just repeated wave behavior, where if you get, if you were to take a step back, you would see this over and over and over again. Okay, but we're only focusing at one period for cosine, which goes from 0 to 2 pi. Okay, we have the 5 critical points like we discussed in the sine video. Now the critical points are in a different pattern here. Okay, if a sine wave, if you recall, the second video that we put together on that, starts with an intercept, then goes to its max, then an intercept, then a min, then an intercept. So you see here, intercept, max, intercept, min, intercept. That's a sine wave. A cosine wave goes max, intercept, min, intercept, max. So you should write that down. We have max, intercept, min, intercept, max. Okay, these are the 5 critical points in this pattern for a cosine wave. We're going to rely on you understanding that pattern when we start to actually graph these things that look a little bit more scary. They look like this. So we're going to get to this at some point in the near future, but we can't really get to that unless you understand how cosine waves are supposed to be behaving. So we still have a period that goes from 0 to 2 pi. Okay, we have 5 critical points there in a different pattern. But other than that, how we get these numbers by plugging in angles and taking coordinates, very similar to what we did with the sine wave. Okay.